Hello, everyone. Welcome to our CES. My name is Andy Deal. I'm your host. And with us today, we have Madison Rye. Madison is Saratech's VP of PLM and Application Engineering. Today, I'm very happy to share with you this presentation. This was a presentation that Madison did at Realize Live 2025 in June in Detroit, and it was a very popular session. So we thought we'll bring it online and share with all of you who may not have had a chance to see it or were not able to attend Realize Live. With that, I'm going to pass it over to Madison.
Thanks, Andy. Thanks for joining me today. We're going to talk about connected BOM, and we're going to do a concrete example, so hang in there with me. Anytime you start any project, this infinity loop represents your product life cycle, mechanical, electrical, and software. So when you're in program planning, you need to know a target set of requirements, a target schedule, and a target cost. And you move to marketing, then you move to quoting and ordering, design and development, test and analysis, all of the aspects of manufacturing, shipping and logistics. You may have installation and commissioning, may not, or service. You may do your own service or not. But you take all of this information that's learned during this entire life cycle, again, mechanical, electrical, and software, and you put it back into engineering so that you can have continuous improvement. All of this information is your digital twin. So it's not just your CAD representation of your physical thing. It's actually all of this, so that when you're sitting here in design or planning, and you're thinking, we'd like to make this change, you can tell what it affects. Is it a critical dimension? Do I need to change my quality documentation? Is tooling going to change? I need to understand the full impact of that. And in order to do that, all of this information has to be digital, and it all has to be flowing along this life cycle seamlessly. So when you take something out, and I see that people do this all the time, they take the CAD BOM, they put it into Excel, they add some things, put it into, type it manually or import it into ERP, you're breaking this chain. You're breaking this flow of information so that it has to be redone. Now you have two sets of data for the same thing that are in different systems, and you've got to keep those up to date. Takes longer, and error can occur. So everyone is trying to digitalize this life cycle, and the digital twin, which is all this information, needs to flow through the digital threads that are on this life cycle. So you might have a digital thread, advanced engineering, where you look at software, mechanical, and electrical design. You might have smart manufacturing as another digital thread. All of it has to flow seamlessly, and that's where you get major impact to you get to that better, faster, cheaper you're looking for. A lot of times when we go in and we see customers, maybe they have a legacy system that they're trying to import things in, and their Teamcenter version might be out of date. They've got ERP and MES, but they're not connected. They've got different tools over here, and they're not connected either. What we want to get to is where we have a future state that looks something like this, where you have Teamcenter as the backbone of your PLM, your engineering team, you have CRM, ERP, MES, but they're all connected to a service bus, data lake, and warehouse with master data management, so you have the right governance, and you have the right layout and attribute mapping between all of these systems, and then you decouple them so that you can upgrade separately and so forth, but everything's connected here. When you do this, you can really take advantage of reporting and analytics and AI and all those tools to be able to do things like predictive maintenance and even offering services for uptime and so forth when you have all of the data. Again, it really drives down the engineering time. For example, if you have CTO, configure to order, you might have a sales configurator in Salesforce where your dealers or your customers go in and they select the different features that they want, and then they enter that. With some customization, you can actually connect these two systems and drive the product configurator in Teamcenter right from the sales configurator so that you go from 150% down to 100% BOM, even in the mBOM and bill of process. You hand that off to your ERP system and you're ready to roll. So once that's set up, when a CTO comes in, an order comes in that's configured to order, no engineering is involved. It just flows. That's the power of doing this. And even if you do have some engineering to order, you can still take advantage of the reuse of the things that aren't going to change. use your engineering bill of materials to assign the new products or the new parts that need to, and then those are placeholders for engineering to come in and create the electrical or mechanical or software pieces that need to be made. So in order to do this, we need to have connected BOM, and this depicts the BOMs that we're talking about: design BOM, engineering BOM, manufacturing BOM, and service BOM. But I like to look at it because I'm an Excel geek. I like to look at it in Excel. I live in Excel, so it's not as pretty as that slide. But you have, when you save a top-level assembly into Team Center, you're going to see that top-level assembly's BOM. So you're going to see the sub-assemblies, all the piece parts here. Here's the little decoder, magic decoder ring down below that shows you these are sub-assemblies, these are parts. Now, when you come over to the engineering BOM, and I'm going to show you this, what it looks like in Team Center in just a second, but you can do partitions or modules or groups. So this can align with your product breakdown structure and your work breakdown structure so that the team responsible for chassis has all of the things they need in chassis, and they see that in this grouping. So this is just another view, another way to look at this. But here you can also do things like add in your mechanical and electrical or your software and electrical pieces. You can also add in your configurator pieces. So now you have this green and red part and a white and black part, but green can only go with white, red can only go with black. I create the rules around that. Again, I'm going to show you that in a minute, so that it drives the BOM to be what I need it to be when those choices are made. You can also have a different engineering effectivity here. So instead of just, I've replaced Rev A with Rev B, now I have Rev A going out at this unit number or this product number, serial number, or this date, and Rev B is coming in. Then I can move over to my manufacturing BOM, and I can see that I have a plant, a line, a cell, a workstation, get as granular as you want, but I have these same parts here. So all of this is just a link to where this original part is. So you see it here, but it's tied back. So if anything changes on this side, it flows all the way through here. Now maybe I assemble these two in a different part in the plant or at a vertical, and I need a manufacturing assembly to account for that. You don't need that over here. People call these ghost or phantom assemblies, but you definitely need it here. And a lot of times this gets lost in the shuffle of how do I relate that back to here? Well, now, since this part is directly tied to your engineering BOM, directly tied back here, you don't ever have to worry about trying to find the right thing. It's all connected. And this is just a view of your router. So why is this important? I think I probably told you this already. It's because you have the same set of data that you're working with. Everything's in sync. The changes flow. If you have any certification, traceability, all of those things are very easy to do here. And of course, faster time to market. So I want to do an example, and I'm going to use Legos because I love Legos. I think everybody does, but it represents my 1996 Dodge Ram pickup that I love because it has some lovely new features like this defrost feature here that you see. And we're going to use that because I did an analysis way back on the brake rotors, because the brake rotors are pretty hot when I change them now. And I don't remember as a kid them running that hot, so I wanted to see what the difference was. So I made a brake rotor assembly, and I'm going to use that here. But just looking at the engineering BOM on this side, I have my product variability here. So maybe I have a set of standard brakes and a set of performance brakes. You would see that in the CAD. You would see both sets of brakes here in the CAD model. And that would be the 150%. And you could configure that down with your choices to 100%, or you can do it here in the manufacturing, and you can even do it on bill of process. So when I move to my manufacturing BOM, you'll see I have my 100% BOM. I've just got one of these variations, but I got my parts list so that I know exactly how many piece parts I need in each station. And then I have my instructions here. And the work instructions are fantastic in Team Center because they tie back again to the CAD or ECAD that they go with so that you can reuse those pictures. So again, and I see this all the time when I go to the plant, I'll see a station and there's this laminated piece of paper up there with a work instruction on it, and it's like, 2 years old or something. It's not up to date because the minute you print it, it's out of date. This updates automatically and you can see it electronically. So what does that look like? Well, here's my brake rotor that I did my analysis on. And here's what it looks like in Solid Edge. And I just displayed the names instead of the part numbers, but you could do either, just a display setting. But Here I have my brake rotor assembly, my rotor, my shoulder hub, my caliper assembly that has a piston, dust boot, seal, bleeder screw. Then I have my brake line, brake pad, guide pin, all these things, the material, all the properties, you'll see those. And I blew it up here, but this is what it looks like in Team Center. So you'll see over here I have my design BOM, and you'll see I have my brake rotor assembly, the rotor, the shoulder hub, caliper, all the parts that go in the caliper, um, the brake pad, brake line, guide pin. So same thing here. And then if I scroll, you can't see it because I got a split screen, but all the attributes are hidden. One's here, description, but the rest are hidden. But there's an attribute that you can choose to include this in your engineering BOM. So literally with one click of a button, I can create an engineering BOM. You can see now that I have a P underscore. So this is in Team Center, a design item. This is a part item and a part object in Team Center. So don't get hung up on the P underscore, because if you want to pass this to ERP, you can splice that off, or you can put a D underscore here and P underscore here, it doesn't matter. So when you, but what this allows you to do, again, is it ties back to the parts that it came from. You can see that I still have visualization for both sides. And now I can go ahead and add my software and electronic parts. I can do my finish and color. There's new color rules. I'm going to show them to you in just a minute. So this allows me to add things here that I don't necessarily want over here when I'm doing the design. And again, I can do the partitions here if I wanted to. So let's talk about Configurator. Again, this is going to line with your product breakdown structure. So you have your body exterior trim, you have your hubcap. This is a group, this is a family, and here's the features. I can assign my feature numbers, chassis, I have brakes, I have my standard brake and my performance brake here. Well, what if I want to add a brake? I want to add a towing brake. I just go and click add and add that as a feature here. It's as easy as that. So originally when you start this, what you're going to do is create a dictionary. And in that dictionary, you're going to put all the features, maybe for a family or maybe for your entire product set. All of those features can then be reused in what's called a configurator context. And what that means is that I'm now saying for these specific models or this family, I'm going to use this configurator context. These are the features that are available in that family model, or the features there that can be reused. Now you do want to do this in 2412, because in 2406 the reuse is a little bit clunkier, but in 2412 it works great. I just pull in the features that I want and it brings them right in here, and then I can use them for this specific set of models. Now what I want to do is say, okay, if I have this standard model and I have the standard brakes, I need the standard hubcap. The other one's not going to fit. I don't have to be a coder to do this. I just click, I want to add constraint, I want to add an inclusion rule, and then I check the boxes here. I want the standard, I want the 357, which is the standard brake, and I want the standard hubcap. So it tells you there's this condition that says if the brake selection is 357 and the model is standard, you're going to get this hubcap that's standard. Behind the scenes, it's doing the code for you, so you don't have to worry about it. And that's what's going to drive your BOM down to from the 150 to the 100%. So now when I come in and I say, okay, now I want to look at a variant configuration, and I go to my brakes and I say, well, I'm going to select that standard brake. Guess what? I only get the standard hubcap because that's all that's valid for this. And then I can have a valid and complete configuration. So I can go through and create all my rules like that, and that's what then drives my BOM. So here you're going to notice that there's no variant rule here. So now I would take that configurator context that I just made and I would apply it to my 150% BOM here. And that's what would then drive the rules that I just created in the configurator. I want to talk about the colorized rules. These are new and very powerful. And again, you probably want to be in 2412 or even 2506. There's some good features there, and I'll talk about that in just a second. But you'll have this new thing called finish type, and you'll see less finish, none, or color. So this means it's not a colorized part. It's a color part. It's a bolt, so it doesn't have a color. This means that it's the non-colorized base part, and this means that it's the color part. So I have standard black, and then I have it tied back to the color or to the non-color part. So what this looks like, and you'll see that I've got my configurator context applied here, but this tray has black. Now I want to make a gray one. So you'll see in here, the first rule is standard black, and I have this finish is matte, and this is black. And I can display the words here if I want to, but you can see black and non-metallic finish here. But anyway, I want to create a gray one, so I want to make a new one, and that's what it looks like. I get another column here, and again, I don't have to be a coder. I can just check. I want to explode into a gray part now. I can do them all at once. I can do them one at a time, doesn't matter. But now I see down here, I have a pending gray tray that's going to be created. And this is going to be tied back to the original colorless part, and it's going to get a part number. Now the caveat here is you can't put in your own part number yet. You have to do some customization to do that we've done. But most people want the base part number and then a dash and 3-digit color code or something like that. That's coming in a future version. I think it's the end of it maybe 2512 or 26, but it's coming to do that. But it gives you the next available part number, but it ties it back. So you can do your full color explosion here, and then you can you can pick non-metallic and gray. Now I have a non-metallic gray finish. So moving on to the manufacturing BOM, I can see here that I have my mBOM collector and a parts collector, and this is that phantom assembly that I was talking to you about. You can have this phantom assembly, which is really not phantom anymore because we can see it. So, but you can have your manufacturing assembly and your manufacturing consumables, your parts, and then maybe you have a shipping assembly, whatever, but this aligns with your bill of process. You have your plant, your process area, process line. You can get as detailed as you want, or you could just have plant line station. Just it depends on how detailed you want to get. But inside there, you would select the operation, and then your equipment and your resources, and then of course, your consumables and your parts. So in that specific operation, you're going to see all the things that you need to have to be able to do whatever it is you're supposed to do there with the instructions that need to be done. And those are written instructions. And Bernard next week or next month, I guess, is going to go into this in a little more detail. But you set up, and that was this is the bill of equipment here. You set up these templates ahead of time, so you know what your plan is, you know what your department, your lines are, your stations, what equipment you have. All this gets set up, and then you just reuse it. And that's another powerful thing, is that it makes it a lot faster. But again, all of it's connected back to the parts that it goes with. So any change that happens flows through all of these changes. This is what your router might look like today. You have this guide pin, brake pin, shoulder hub, but then you have this brake rotor. These are purchase parts. Then you have this rotor, but you're buying the casting, so it's a foundry part, and you're doing some work on that. And then and this is the route for that. And then you have your brake line, which is a Bundy tube, raw material, and you got to do your mandrel bending on that. And then you have this caliper again here that you've got to buy the casting for, and then it goes into an assembly and it gets kitted. So all of this information here with the routes, you might see today, and you can do that same thing, but now it's connected, so everything, changes. So the process is create the templates and create the plant, create the work package. The mBOM comes from the eBOM. You drag the parts in where they belong, and then you use the BOM in the bill of process so that you could specify what parts actually go into that process. And then of course, you have the bill of equipment that is used there. And you don't create it, you actually just reuse what you have. So what does this look like in Team Center? The engineering BOM here is, remember, we looked at that split screen of the design. We had the design and the engineering. Now we're looking at the engineering BOM here, the P_parts, brake rotor and all of that. On the manufacturing side, I'm going to reuse some of those parts, but now I also have some packaging and labeling, because I'm going to kit this to send it to the line. I'm going to kit this to send it to the line. I'm not going to put the caliper on the rotor and send it in. I'm going to package that up. The rotor's going to have some oil with it. Now this is an interesting thing too, because you make some design decisions up front, and those revolve around, do you want consumables in the mBOM or just want them in the bill of process? Some people just assign a generic number to the cost for consumables. Some people want to have the exact number, so they specify exactly how much oil should be used and all of that, and the weight rolls up. So it just depends on how you want to do it. And again, Bernard's going to talk more about this next month in his presentation. But you'll see that there are a lot more things here. You have, the raw materials, the assemblies, the packaging, the labels, and all of that that go with it. And this is what it looks like then in Team Center. You have the parts, and the nice thing here is it tells you it's an alignment. So I have my caliper here. I have my caliper assembly here. These are the, the plant and the department, and then I have the caliper finished, the casting. So some of these parts I don't have over here because I don't need them on the eBOM part, but here I do need them. But it still tells me I'm in alignment because I have all the things that I need from here consumed over here. As I use them up, you can imagine you have it. That was my lovely fun thing to do before when I was at Cummins is we would have to put a Rev A and a Rev B, and we would go down all the lines and highlight what was different. Here it does the alignment for you so you can focus on the engineering work. You can easily see what's not consumed and what is consumed. And then when a change happens, it'll show you, highlight the change and say, do you want to consume it over here? And you can just easily make that change. So these are the things that I showed you before, the collector that shows what plant, what department, the assembly, and then, the finished caliper, the casting, and so forth here. Now, the next thing would be to look at the bill of process, and that would be to align here with your department, your line, and your workstation, and then you would go into the process planner and put the parts and the instructions and the equipment and all of that in that station. And again, Bernard's going to go into more detail on this in his session next week, but that's what it looks like from that slide that I showed you before. Process area line, station, operator, machine, process, all of that information comes in here. Now, we didn't quite touch on the service BOM, but you can also connect a service BOM. You can do this by serial number once it's an as-built BOM, because you might have a non-conformance or something you have to replace in the BOM. Now you have a service BOM that comes out of the plant, and this will live with the thing forever. So you can actually, keep that up to date with when a technician replaces the part, it updates in that BOM. So now you have serialized work instructions. With my truck, I have 1990s Dodge Ram pickup truck, and I have to go figure out what's on mine and what's not. And the pictures, let me tell you, are horrible. But these are pictures right from CAD. The rendering is great, and you have specific work instructions to exactly what's being worked on. And then, of course, you can collect all this information and use it. And that's where you really get the power of reusing the information that you get. So this is a big picture. Where do we start? Well, I always say the starting place is phase 0. You don't want to jump into technology until you understand what your process is today, what your data looks like today, what the people are involved, the technology you're using today, and then where do you want to get in the future? Because we found things like part numbers different in ERP. Some people have completely different part numbers. They're not even the same. Missing data. Sometimes you'll see somebody stuck a part number on the drawing, typed it in because there's not a part for it in CAD, so they just put it on the drawing. Well, now you have a reader that's reading the drawing and typing that into ERP. So it's not actually in the CAD BOM. We find metadata misalignment, like you have a bleeder screw description here and you have the actual call out on an M10 screw here. Color part numbers, you might have a red and black, and those have different part numbers, but they're nowhere over here. And now you've got to keep this BOM, and this BOM up to date with this BOM. And that's a lot of work. So again, the power comes from everything flows through. So you start with that initial data assessment, process assessment, really looking at where you are today and where you want to get. And you can also take a look at commonality and reuse, because everything flows from there. If you can reuse things, and I see engineers doing this all the time, they're like, oh, I couldn't find the part, so I just recreated it. It was simple, it was a bracket. But the cost of carrying that bracket is $15,000 when you consider, and there was a study done by the Navy on this, when you consider that you've got to do change management on that, you've got to carry inventory, all of that, is a cost to the company. So if you can reuse and modularize warranty comes down, engineering time comes down, manufacturing time, it all flows from there. And then you can move into the phases as your business requirements, and how much change you can tolerate happen. So phase 0 is a must. You got to have legacy data. You might have legacy data with assemblies, and you got to figure out how you're going to handle that. And there's different ways to do that. And again, Bernard's going to talk more about that next week. And then, and this is one of the topics he's going to discuss, which having a vertical mBOM, and he'll talk about that. And then that session is August 7th, 11 a.m. And I'm happy to say it's a great session. So, and if you want to, you can participate in some of our training classes too. Feel free to give us a call and reach out, because we'd be glad to hear from you. So now I will take any questions that, Andy, you see in the chat window or anywhere else.
Yeah, thank you very much, Madison. I know that just flies by, but in 30 minutes we can only do so much. So this is the time for Q&A. So if you have any questions, please enter into the chat box and I'll address them to Madison. And while we're waiting for questions to come in, Madison, so we work with a lot of customers doing this. What's the biggest hurdle that you see over and over again to getting something like this started? Of course, you
Yeah.
gave the roadmap where to start, but what do we see that are
Yeah,
out
it's a
there?
great question, Andy. And, it really is getting over the legacy, how the sins of the past. People do things because they got to get their job done, like taking shortcuts and putting something on a print. Those kind of things are the things that are biggest hurdle. People look at that as overwhelming to try to figure out, how are we going to deal with this legacy system or this legacy configurator that nobody knows how to use anymore, or the legacy data that somebody built and it's all out of whack. So those are the things that people struggle with, because everybody's got to do their day job, and there's nobody really assigned to fix that. And that's where we can really help. We can get in there, assess the situation, figure out where you want to go, and really help drive that transformation for your company. And it happens not overnight, it happens in steps. You break off a small piece, you do that, you apply it, and then you move to the next step, so that you're not overwhelming people with change, and you're driving the next step with the improvement that's made from the previous change.
All right, thanks. Another question we have is everything you're showing today completely in the Siemens ecosystem? What if you have multiple CAD tools or from different systems?
Yeah, great question. So Siemens is built on three pillars. One is, the complete digital twin, and I showed you that in that product life, the infinity loop slide I had. Two is that it is an open ecosystem. So if you have SolidWorks, if you have an ERP system that's different, we deal with all sorts of, Microsoft Dynamics, SAP, JD Edwards, just tons of them. So if you have something that's different, we have integration for all of that. The key is to integrate the systems to pass the information so that you have a single set of data. It doesn't have to be a single system. In fact, it shouldn't be. It should be ERP, PLM, CRM, and CRM, ERP, PLM, and MES. So those four systems, all of the like independent analysts say, are the important systems for this transformation. And they don't have to be Siemens systems. We can integrate those.
Fantastic. We are right now out of time. Madison, thank you so much. I know you're a very busy person. Thank you for being here and sharing this very useful information with us. Everyone else, thank you for joining us today, and feel free to contact us if you have specific questions about your situation or your organization. I'm sure we can help out. Thank you so much.
Thank you, Andy. Bye-bye.